polynomials. Let us move on to the next topic, types of polynomials. Now there are different types of polynomials depending upon the degree. Depending upon the degree means depending upon the highest power. So let us see the first type, linear polynomial. Here is the definition. So polynomial with degree 1 is called as a linear polynomial. Polynomial with degree 1 is called as a linear polynomial. Now what is the meaning of degree? We have seen in the previous slide. Degree means the highest power. Degree means the highest power. So such a polynomial whose highest power is 1. A polynomial whose highest power is 1 is called as a linear polynomial. Let us see an example. So here are few examples. Let me concentrate on this example first. X plus 4. Which is the variable used over here? The variable is x. What is the power of x in this case? As there is no number written over here, the power of x is 1. Therefore, we say that the highest power of this expression is 1. Therefore, it is a linear polynomial. Again, if I move to the second example, which is the variable used? The variable used is y. What is the power of y? The power of y again is 1. Therefore, again, this can be called as a linear polynomial. Note one thing, that the number 3 is not the power. Number 3 is not the degree. Number 3 is just the coefficient. In the first example, x plus 4, we can say the highest power is 1 because there is no other x term used over here. That is, the degree is 1. Therefore, it is a linear polynomial. Again, here in the second example, 3y raised to 1 plus 8. That is, again, the degree is 1. In the third example, again, I can say the power of m is 1. And in the fourth example as well, the power of z is 1. So, in all the cases, the highest power is 1. That is, the degree is 1. Therefore, they are all linear polynomials. Now, let us move on to the second type of polynomial, quadratic polynomial. The polynomial with degree 2 is called as quadratic polynomial. Degree 2. That means we know that the highest power has to be 2. So, let us see some examples. So, here are few examples. Again, let me concentrate on the first one. So, this is the first example, x square plus 4x minus 9. So, here the degree of this polynomial is 2. Why? Because the highest power of x is 2. Here the power of x is 1 and here the power of x is 0. Therefore, the highest power is 2. Therefore, it is a quadratic polynomial. Similarly, in the next examples as well, you can clearly see that the power of y here is 2. The power of y here is 1. The power of y here is 0. Highest power is 2. That is, degree is 2. Therefore, again, this is a quadratic polynomial. And this example is again an example of quadratic polynomial. So, we'll move to the next part, that is next type, cubic polynomial. So, polynomial with degree 3 is called as a cubic polynomial. Again, a simple one. The highest power will be 3. Let us see how. Here are a few examples. So, this is the first example. You can see that the highest power of x in this case is 3. Here the highest power of y in this polynomial is 3 again. Again 3, highest power. And in this example as well, the highest power is 3. Therefore, they are all examples of cubic polynomial. Bi-quadratic polynomial. Bi itself means 2. Bi means 2. And quadratic itself was 2. So, 2 into 2 will ultimately give me 4. Therefore, you can check the definition as well. Polynomial with degree 4 is called as a bi-quadratic polynomial. Let us take few examples. You can guess the examples. It is very simple. The highest power has to be 4. So, few examples over here. If you check properly in the first example, that is x raised to 4 plus 4x minus 4. The highest power is 4. The second example as well, you can clearly see that the highest power of a is 4. That is, the degree is 4. In this example as well, the degree is 4. Therefore, they are all examples of bi-quadratic polynomial. Now, the last one, constant polynomial. Polynomial with degree 0 is called as a constant polynomial. Let us see a few examples of constant polynomial. Now, here are a few examples of constant polynomial. -7, 2, 10, 11. Now you might guess, how can these numbers be constant polynomial? Because we have learnt in polynomial definition that polynomial is also an algebraic expression, and we know that an algebraic expression consists of a constant and a variable. But you can clearly see there is no variable used over here in any examples. But I'll tell you how the variable has to be created. Now if I take the first example of -7, so let me take -7 over here. Now according to the definition, they are saying that -7 is a constant polynomial, but since it is a polynomial, there has to be a variable over here, and we can see there is no variable attached. But we can create a variable over here. Say for example, I can take y. So I'm taking y to the power 0. Y to the power 0. Now what will happen? I know that any number raised to 0 is 1. So in the next step, what I can do is, I can say -7 multiplied by y raised to 0 is 1. Therefore, I'll get -7 into 1 is equal to -7 itself. So I got this result, that is -7. So ultimately, this result and this result is the same. So what we can do is, when we get any kind of a number, say for example 2, which is the second example, we can write down the same number by attaching a variable raised to the power 0. That is, I can write down m over here raised to 0. So the overall result is going to be 2 only. It is not going to change. Therefore, if you observe properly in both the examples, the power of y here that we have taken is 0. Power of m here is also 0. Therefore, we can say that all these numbers are constant polynomials, because we can write down a variable further and then write down raised to the power 0. So in this way, all numbers are said to be constant polynomials. So you can clearly read over here, all real numbers are constant polynomials. Let us move on to the next topic, that is types of polynomials depending upon the terms. Now, your first polynomial is a monomial. So monomial is a polynomial having one term. So polynomial having only one term. Here are a few examples like 4x, 2y, 9m cube, -5a raised to 4. These are all examples of monomials because they are all single terms. They are all single terms. That is, this entire 4x, if I say, this entire 4x can be considered as one term. 2y, this is a single term. Don't calculate these terms as different terms. 4 and x are not two different terms. If it was 4 plus x, then we can consider 4 and x as two different terms. Also, if it was 2 plus y, it would have been considered two different terms. But 4x means 4 multiplied by x. 2y means 2 multiplied by y. So they are considered as one term only. Even if I write down like this, say ABC, this is assumed to be one term. These are not three different terms. If I write down a plus b plus c, yes, then they can be considered as three different terms. So 4x, 2y, 9m cube, -5a raised to 4 are monomials because they are single terms. So always remember, whenever multiplication is used between the terms, they are assumed to be one term only. In case if addition or subtraction is used, if the same one was like 4 minus x, then also they will be considered as two different terms, or 2 minus y. Then also they would have been considered as two different terms. So if plus or minus sign is used, then only the terms get separated. Otherwise the terms don't get separated because of multiplication or division. Let us move on to the second type, binomial. So polynomials having two terms. Is called as a binomial. So in a binomial, since there are two terms, there will be an involvement of plus or minus sign. So let us see how. So here are a few examples. 4x plus 9. So there are two different terms. One term is 4x and other term is 9. So they are separated by this plus sign. Again, similarly, if you move further, 2y minus 3, 9m cube plus 2m. minus 5a raised to 4 minus 11a. So if you observe properly, if they are separated by plus or minus sign in the middle, then they are said to be binomials. Let's move further. Trinomial. So polynomial having 3 terms is called as a trinomial. So 3 terms. Now we are going to get 3 different terms, again separated by plus or minus sign. So here they are: 4x square plus 5x plus 9. Since they are separated by 2 plus signs, there are 3 different terms now. Again, 2y raised to 4 minus 2y minus 3. Again you can see 2 subtraction signs. So 3 different terms you are getting. Next example, 3 different terms. Again in the last example, we are getting 3 different terms. So if there are 3 different terms, then it is tri. Tri means 3. That is trinomial. But what if there are more than 3 terms? So if there are more than 3 terms, say for example, if a polynomial contains n terms, then we call it as polynomial with n terms. Let us see how. So here is a polynomial. So how many terms are there in this polynomial? 1, 2, 3, 4, 5. So 2x raised to 4 is one term, minus 3x cube is second term, 8x square is third term, minus 11x is the fourth term, and 33 is the fifth term. So there are 5 terms. So it does not have any specific name, but we call this as polynomial with 5 terms. So we can call this as polynomial with 5 terms. If I have one more example, I'll take a simple one. Say a plus b plus c plus d plus e plus f. So if I have a plus b plus c plus d plus e plus f, so there are 6 terms: 1, 2, 3, 4, 5, 6. So we can call this polynomial as polynomial with 6 terms. So in this way, you have to just count the number of terms and write down. So we started with types of polynomials depending upon the degree. So if the degree of the polynomial is 1, it is said to be linear polynomial. If the degree of the polynomial is 2, it is said to be quadratic polynomial. If the degree of the polynomial is 3, it is said to be cubic polynomial. And if the degree of the polynomial is 4, it is said to be bi-quadratic polynomial. Similarly, depending upon the number of terms, if the number of terms is 1, we call it as a monomial. If the number of terms are 2, we call it as a binomial. If there are 3 terms, we call it as a trinomial. And if there are more than 3 terms, say for example, if we are having n terms, then we call it as a polynomial with n terms. Also, you have to remember one more thing: division and multiplication does not separate the term, whereas addition and subtraction will separate the terms.